talk some series and summation notation. So series, okay, series is an indicated sum of the terms of a sequence. We were doing a sequence last time. It just gave us a list of all the numbers. So a series is when you're going to add up that sequence. Now, if it is a finite series, you can actually get a total amount by adding all those things up. If it's infinite, you cannot add them all up because it goes on forever. We're going to go pretty general with this. So today we're talking about summation notation for series. So if you look at this example, we have 3 plus 6 plus 9 plus 12 plus 15. That's a finite series because it ends at 15. So sure, you can add that up, but that's not what we're working on here. We're working on using summation notation. So when you write this, you'll look here, we've got this Greek E looking thing, which is called a sigma. So if you look underneath it, it says I equals 1. So I equals whatever, that's the term that you're starting with. And it's always going to be 1 for us. So like here's our first term, our second term, our third term, fourth term, and fifth term. So that's what it represents down there. Now you could write K equals 1. You could write whatever. You could write N equals 1 like we did with the sequences before. That's fine. So this is like your starting place or your lower limit or lowest amount, whatever you want to call it. And then up here, the number up top is like your upper limit. So it's how many terms, so we're maxing out at the 5th term because it's a 5 up there. And then you'll see the last thing here, this 3i, this is like the rule for that sequence. So you'll see that each time it's 3 times the term number. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 20. Cool? So this side is the rule. Now you might see here it says 1 to 5 odd 3i. It was supposed to be of, a little typo. Hopefully when I made the copies in person, I fixed that. But if you're remote, you might be out of luck there. All right. So what do we got here? Now you'll notice with infinite series, they go on forever. You got the dot dot dot. So there can't really be an upper limit. So you just write the infinity symbol up there, which is just a sideways 8. So let's try some of these out. Write each series in summation notation. So we're going to need our sigma first. If you just write, the squiggly, you don't need the little legs on it. I just like mine to look beautiful, like I say. So remember, down here is like our starting term number. And for all these, it's going to be 1 because I'm going to give you the first term. Now, how many terms do we have? Well, there's 1, 2, 3, 4, 5 terms. So our upper term limit will be 5. And then over here, we write the equation. So how can I go from 1 to 3, 2 to 6, 3 to 9? Every time you're multiplying the term number times 3. So we will say 3i. So let's try this out. All right, there's 1, 2, 3, 4, 5, 6 terms. So we're starting at 1. We're maxing out at 6. Now you're alternating positive and negative. So if you remember from before when we had just the sequences, we had to do -1 to the n power or the n plus 1. Now if it starts off negative, you could just write to the n power. But we're using the variable I on this one. Again, if you wanted to put n equals 1 down there, that's fine. Just keep it consistent, it doesn't matter. So we'll say -1 to the I power. Okay, so that'll handle the alternating. And then, so kind of ignore the positive negatives. Now, how are you going to go from 1 to 2, from 2 to 4, from 3 to 6? You're multiplying by 2. So we'll say -1 to the I times 2i. 2 times the term number. We'll practice more. Okay, we'll start the next video. I see you panicking over there, but don't. We'll be fine, okay?